Assalamualaikum and a very good morning. I bid to the teachers, the people who are watching this, and my fellow teammates. Today, my Group 4, will be discussing about carbon dioxide CO2 emissions by transport from 1998 to 2018. We are going to be discussing this in our slide today. So first of all, these are our group members. The first one is Akasha bin Azhar. The other one is Ashmal Haikal bin Amalu Zaman. And then there's me, Muhammad Zafan bin Ibrahim. And then there's Muhammad Izarul Hakimi bin Muhammad Aznul. And then there's Muhammad Harith Iskandar bin Adnan. So our introduction is, this presentation summarizes task 1 and 2 of the MAT009 assignment, focusing on the use of numerical methods to analyze real-world data. Task 1 explores CO2 emissions by transport over time, involving data analysis and preparation for numerical methods such as interpolation or regression. Task 2 applies Simpson's rule to estimate the area under a graph based on given function values for different numbers of coordinates. 5 and 7 showcasing an important technique in numerical integration. This will be discussed later in the slide as our other group members will be presenting. So first of all, this is the table of actual carbon dioxide emissions by transport in China. As we can see, from the year 1998 to 2018, the CO2 emission by transport increases until it reaches this number. So this is the actual graph of the transport. As we can see, it increases, then decreases a little bit, and then it decreases, but the increase is not high. Then it increases until it increases exponentially around 2010 to 2015. Then to about 2018. So this is an exponential graph that we have calculated using PT. As it shows, it goes up exponentially.
Hello, I will tell you about how to find the particular solution. So given the general solution is PT equals to AE to the power of KT. So to solve for A, we let that 1998 to be T equals to 0. Substitute the 0 into T, and we got AE to the power of K times 0. In 1998, the CO2 emission is 140285080 equals to A e to the power 0. So E will be equals to 1. So we got that A equals to 140285080. Then to solve for K, we going to let 1999 equals to T equals to 1. So substitute T equals to 1 in the PT, and we got 140285080 e to the power of k times 1. In 1999, the carbon emission, the CO2 emission is 157361680 equals to 140285080 e to the power of k times 1. So we calculate, and then we got that k equals to ln 1.1217. Hence we got k equals to 0.1149. So the general solution, we got P T equals to 140285080 e to the power of 0.1149 times T.
Now we would like to proceed on the use of the particular solution that was explained before. So we could use that particular solution to predict a future and predict past. For example, if we want to find the commission of carbon dioxide for the 30th year, start from 1998, we could substitute the value 13 in the calculation, and we would get 624,765,661.5. And if we want to predict past, we will substitute the value year that we want with negative to show that it was in the past. For example, if we substitute negative 13 in the formula, we will get 31,656.4.
So without further ado, let's start with our question. Question first. Are the values calculated from the particular solution accurate with the values? And we get that the answer is yes. The answer is highly accurate, although not on the point of the actual value. It is indeed quite close. This is because the percentage error that we calculated is very small. And let's move on to the question 2. Find the percentage error, if any. So we take the value of T13, which is from 2011, and we use the formula calculated value minus the actual value and divide it by the real value and times the answer with the 100. And we get the value is 0.4624%. let's move on to the next question. If there is any difference between the actual value and the value calculated from the particular solution, what do you think it is so? So the difference in may actually caused by the sudden jump in the CO2 emission during 2000s. This is maybe because there are sudden demand in the energy making, and thus making the CO2 emission higher during the year.
Okay, now we can move on to the question number 4. What has affect the CO2 emission growth in the past? The CO2 emission growth in the past is primarily affected by the industry activities, which is because of the burning coal. Other than that, it was caused by transportation in China, as motorcycle, car, and etc. After that, there are also other factors, including air conditioning, refrigerator, and the most importantly, human, as a human emits CO2. Okay, now we move on to the question number 5. What do you think might have affect the CO2 emission in the future? In our opinion, the main factor that causes the effect of the CO2 emission in the future is the rate of the fossil fuel is being used, which mainly focus on the energy generation, which is most crucial part for the country to run. Other than that, it's also because of the transportation in the country. As logically thinking, as more time pass, more people will produce, and naturally, more car production will be made, which will increase the CO2 production.
So next, we move on to task 2, which is Simpson rule. So why people use Simpson rule at the first place? People use Simpson's rule because it's a numerical method for approximating the value of a definite integral, especially when the function is difficult to integrate analytically. The function is unknown at certain points, like when you're working with estimated data or measurements, and if you want a fast and reasonably accurate result without needing symbolic math. Alright, so this is the question that we get for our Simpson's rule task. So we need to find by using 5 and 7 ordinates. So first of all, if you want to use the Simpson's rule method, we need to determine the value of a and b. So the value of a and b we can get from the integration. So the a is here, which is the half of 11. Oh, sorry. And the b is the 13 here. Alright, so after we determine the value of a and b, we need to determine the value of h. So we're given that we need to use 5 ordinate. But in the calculation of h, we use the subinterval. So the subinterval of ordinate 5 is 4. And then after we know the value of this subinterval, we can calculate for h. So calculating h is actually b, the value of b minus value of a, and then we divided it by the value of subinterval, and then we get the value of h. Alright, next, we need to make a table for x and fx. So for x, the first x is actually the value of a that we are given. And then for the next x is value of a, and we add the value of a with the value of h, and then we repeat the process until we get the value of b, which is 13 there. And then for fx is actually our equation before. So this is our fx, and then we substitute the value of x of each x, and then we get the value of fx. And then we need to determine our alternating coefficient. So to do the alternating coefficient, we put number 1 for the first x and the last x, and then we alternate the value of 4, 2, 4, 2, 4, 2, 4, 2 until we reach the final x, and then we calculate the value for alternating coefficient times fx, each fx, and then we calculate the sum of all of the coefficient times fx that we got before. And then, the last but not least, we can now calculate the value of area under the graph by using the Simpson's rule, which is h divided by 3 and times with summation of coefficient times fx. And then we got the area under the graph, which is since the question asks us to leave the answer in 5 decimal places, so we got 47.38723. And then we repeat the entire process for 7 ordinate. And then we got the area under the graph is 47.55588.
So for comparison, area calculated using 5 ordinate we got 47.38723, and area calculated using 7 on linear is 47.55588. Where the actual area is 47.5945. So in conclusion, for task 1, it is found that the value of CO2 emission keep increasing as time going forward. It's determined that at t equals to 13, the value calculated using particular solution matched with actual data of CO2 emission with 0.46% error percentage. The value for pass at t equals to negative 13 is also calculated using particular solution. As for task 2, area under the graph was determined using Simpson rule. It's determined that the more number of subinterval giving more accurate value of area under the graph.
Okay, this is all from us. Thank you.
Thank you.